Welcome everybody to. Is it the last one? No, it's not the last talk, right? I'm going to talk about Kotlin and Gradle meets Kotlin. My name is Rene Groeschke. I'm working for Gradle Inc. for 5 years, doing mostly working on Gradle core and doing consulting all around continuous delivery and Gradle related stuff. I have a Twitter account, GitHub, so if I run out of time, reach me afterwards. In this short session, we look how Gradle works together with Kotlin. I start explaining a little bit how you can build Kotlin projects with Gradle really briefly because it's quite simple. Spend one slide or so about writing Gradle plugins with Kotlin, and then most of the rest of the time we focus on writing Gradle build scripts within the Kotlin DSL and what we did in the last couple of months around that, and some issues we have, and how it looks like with some live demos. So, who of you is using Kotlin at all? Okay, who of you is using Gradle? Okay, better than vice versa. So, if you're into Kotlin and want to start your Kotlin project, it's pretty simple if you're used to Gradle. The JetBrains guys, they provide a third-party plugin for that. You apply that. It's nothing magic here. Build script. You apply the Kotlin plugin, and then you have to add that standard library dependency. And in Kotlin, you always need to add that. At the moment, that Kotlin plugin is not in the Gradle plugin portal. There's an open issue for that. You can vote. I have a link later on. On top of that, there's a plugin about from the Nebula guys. So Nebula is a short term for Netflix build language. It's actually the open source suite of Gradle related plugins the Netflix guys provided, and they have put some convenience plugin on top of the existing one. So you can resolve it from the Gradle plugin portal using the new plugin DSL. Specify a version here, then nothing fancy, repository. And then, for example, what they do is they automatically add that standard lib. You don't need to do that copy pasting all over the place. And what they also do is, if you have a Kotlin dependency, like Kotlin Reflect or something, you don't need to specify a version anymore. So you can just define the username or group name, and then the version is inferred or is taken from the plugin itself. So that's how you build a Kotlin project. Put your Kotlin files in source main Kotlin. That's it. Second step. So if you want to write a Gradle plugin in Kotlin, that's straightforward too. So we use that Kotlin project I just described with that Nebula plugin, for example. You apply the Gradle API. Who of you have written Gradle plugins before? Yeah, it's fairly simple, right? Compared to other build tool plugins. All you need to do actually is apply or implement one interface with one method. And in Kotlin, that would look like this. So you have that plugin class or plugin interface you need to implement, and you have an apply method. And that's what we do here. We implement that apply method, create a task, hello world, and then we create a task with the do last action. Nothing fancy, nothing surprisingly. So if that's all what you wanted to get out of that talk, you're done. But I wanted to focus on the Gradle scripting frontend and how you can do that with Kotlin. So at the moment, or so far since the beginning, the Gradle build scripts, the build.gradle files, are supposed to be contain declarative description of your build using Groovy-based DSL. Groovy is nice to create an expressive DSL for describing those builds, and what we also offer apart from our own DSL elements, we allow extending your builds with custom DSL elements, like for example Android. Who's doing Android? Oh, interesting, not so much. So that's how it would look like. So with Android, that Android block here is completely coming from an external plugin, nothing we create in the Gradle code base. So you have a declarative build script where you define different product flavors, different build types, all that kind of stuff. So the DSL needs to be able to deal with that kind of stuff. So, but what are the current limitations of that? When the original DSL was designed, or the crucial elements of it, it was not designed for performance. So there are things we do in our DSL, in our Groovy-based DSL, which can hit some performance issues. It's not usually not a big deal in normal size projects, but for example, what we do is in that configuration block, if you see dependencies, compile, and then give a dependency notation. What actually we do there is we rely on Groovy's dynamism, so that you can call a method or declare a method in a build script which is not even there, and that how that is resolved in Groovy is obviously more expensive than calling a native method. So the other thing about that DSL is that it's not that tooling friendly for two reasons. One is okay, it's Groovy, and there are some Groovy tools missing these days. Like there's, I think, no proper IDE plugin for Eclipse at the moment, or nothing that is maintained. The other things that we use some stuff in the DSL or from Groovy, like AST transformation, which makes it really hard for a tool to understand what's going on there. Yeah, so tooling friendliness is something I think we in the Gradle core team also underestimated the value of that. So so we have BuildShip there, which comes with really good Eclipse support or Gradle support in Eclipse. IntelliJ, they provide their own functionality, which is really working well. We see later on. But there's nothing in there at the moment, or not much in there, that supports you in crafting build scripts. It's more about using a Gradle build, right, with BuildShip and also with IntelliJ. So, and what's missing here is a link between crafting build scripts and doing actually writing production code. Like you don't use the same patterns you do when you write your production code when doing Gradle build scripts. So like you can't use refactorings, you don't do you can't dynamically look up documentation, all that kind of stuff. I'm not a JavaScript guy, so I rely on my IDE. I need that support. So that's missing to some degree. So why did we looked into Kotlin at all? Kotlin is quite new. They have been, or relatively new compared to other languages. Kotlin is statically typed in comparison to Groovy, which is not. 1.0 was released earlier this year. It's what I personally really like about Kotlin. It's driven by pragmatism. That's similar to how Groovy started, I think. And it's invented and maintained by the JetBrains guy. So, and that by implicitly means that there's perfect IDE support for that. And we noticed that there's a considerable uptake in the Android community. They want to use more Kotlin. One reason is I think they have to rely on an older Java version, so they can't use Java 8 features so nicely. So that's where Kotlin comes into play with their Lambda support and all that kind of stuff. Yeah, and when you look at when the Gradle team and the Kotlin team first met, or we started discussing how a DSL could look like, there were some enticing opportunities there. So we could potentially have proper IDE support with the code completion, all the refactoring, all the IDE stuff from writing Java or native code in whatever IDE you use. And since the Groovy or the Kotlin team, they also or Kotlin is designed or has proper support for writing DSLs, or it's one of the design goals was to be able to create DSLs. it sounded like a perfect fit to try that out with a Gradle, coming up with the Gradle DSL, while keeping the build scripts clean and declarative with Kotlin. So if you then compare what we would like to have, or what we rely on for Gradle DSL compared to what Kotlin which Kotlin features are there. So, for example, a Gradle build script should be expressive. So, therefore, there's this lambda expressions which makes reading Kotlin code really nice, or provides a nice view on that. You have lambdas with custom receivers, so you have something similar. You can build something similar like the Groovy builder pattern with Kotlin, but being static, right, compared to Groovy. That's a big difference. Readability, so you can extend existing or you can extend existing classes with custom or with more logic. You can delegate to members, all that kind of stuff. Your first-class scripting support, I mentioned that there's this KTS Kotlin scripting support built in. And yeah, Kotlin is designed to run highly performant or be high performance. So whose build is too fast? I guess nobody, right? So builds are never too fast. So performance is always an issue when you work on the build tool. Kotlin is statically typed. I mentioned that makes it fast. It follows a vanilla JVM execution model. It does nothing fancy. It compiles a normal bytecode. You can execute it. You even have control in the way you write your Kotlin code to rely on inline functions. So you can lambdas can be inlined in your bytecode, so that you don't lose any performance there. So it looked like native, like normal functionality without that lambda. And yeah, I mentioned that tooling friendly, of course. So it's JetBrains designed that language. So there's a deep IDE integration, not just for IntelliJ. They provide plugins for Eclipse, and now since a couple of weeks also for NetBeans. Yeah. So, and that's more than, for example, Groovy has to offer at the moment. There's unfortunately no IDE support for Groovy at the moment in Eclipse world. Yeah, there have been some design constraints when you think about moving to a different language or supporting another language as a DSL backend. There are some constraints in the Gradle world. So, like, we have something like 800 plus Gradle plugins in our plugin portal at the moment, and they should work out of the box, right? It should not be necessary if you write your build script in Kotlin that you rely on new plugins or stuff. That should work out of the box. The other one, things like, yeah, you can say something like lessons learned, that we wanted to reduce what some people call magic, like what I mentioned earlier. We use that AST transformations in the build script. I used to say, okay, if you have a build script, just look up org Gradle API project file, and then you see all the methods, all the functionality which is there. I keep telling that in trainings till people come up and say, okay, but there's this task method. How is that possible? And then I have to say, yeah, we cheat a bit. We do AST transformations there, and that's what some developers consider to be magic, which is fair. Then another thing is, if you're coming from Kotlin, or if you used to write Kotlin, it should be idiomatic. You should be able to write idiomatic Kotlin code within the build script. It shouldn't look much different to what you do in your production code, for example. Especially when you think about the Android ecosystem. If you don't switch between your Kotlin production code and Kotlin build script code, that's a big win. And another thing was, of course, that there should be an easy way to migrate your build scripts or your whole builds from one front end to another. Yeah, we hit some challenges. Some we resolved already, some not so much. So first of all, there's this transition you have to do from dynamic to static. So if you look at that snippet here, which is a Groovy DSL, So you have that dependencies block where you say, okay, for my test compile, I have a dependency on JUnit. And actually what that is, it's a method call. It calls test compile with a parameter as a string. And that method actually does not exist. So in Groovy, there's this method not found hook, so you can declare methods which are not there, and then you can react on that in your custom logic. So how would that work with Kotlin, for example? In an initial version, we had that kind of logic to solve that. So you have what you do is you declare a string, which is by definition, I guess, dynamic, and then you call and you pass that dependency as a parameter here. When I mentioned earlier that we want to have nice IDE support and refactoring and all that kind of stuff, that doesn't work if you move everything to strings, right? So we had to come up with something else. What you can use there is in Kotlin, you are able to extend existing classes with your own methods. So and how that works is, so now it looks quite similar to what we had in the Java land or in the Groovy land. So with test compile, and then we pass a parameter just like a method. And the way you can do that is you can extend existing classes there. So for example, we have that dependency handler. And here what I do is I declare a test compile method, pass in the dependency notation, which can be of any type. And then in that method, I just delegate to that add method, which does exist in the dependency handler itself. It's nothing DSL specific. Yeah. Another issue we also had in the Groovy backend is that you have self-referential build scripts. Like in the build script itself, you want to declare dependency which is used within the build script. In Groovy, we solved that a long time ago, but in Kotlin, it was kind of a challenge too. So actually what happens now is if you save that build script, the dependency is resolved, and then you can use that dependency here. Like I apply a plugin, publishing sample, there's a greeting task in there, and then I can use that. Another thing that's not a big pain point, but kind of inconvenience, and we haven't solved that yet, is that the Gradle API uses some patterns which does not work well with idiomatic Kotlin code, I would say. For example, some places still leak Groovy closures in their API, so usually you don't want to call a method which from Kotlin with a Groovy closure, and there are also these action parameters as a Java equivalent for that. In Kotlin, you have lambdas, and you want to use those lambdas. So we have to come up with a solution to maybe to hide these or to make them non-available if you come from the Kotlin world. Yeah, that's something we need to still sort out. And last but not least, I think a general challenge is if you maintain multiple front ends, that comes with a cost, right? You have to catch up with the latest Gradle features, which are currently developed mainly in the Groovy DSL. You have to find an easy way to migrate between them. And we want to preserve some Gradle idioms that have been built up over the last couple of years. So that's another thing or another constraint here and another cost with that. So we have enough time left to do some coding. So if you want to start writing your build scripts in Kotlin, at the moment what you would need to do is you need to change your settings.gradle file to specify the name of your build script, and your build script should be build.gradle.kts. It has to end with KTS. That's a detection in Gradle at the moment that we figure out, okay, that's a Kotlin-based build script. So, and that's basically all you need to change, and then you can start writing your build scripts in Kotlin. So how does it look like? So I have a build script here, just a simple hello world. And here I have that settings file. Here I have that KTS file. And what I can do now is, for example, if I want to apply plugin, now I see that I have Clojure specific code completion here, or Kotlin specific code completion, sorry. And then I can apply the application plugin, for example, and that gives me certain tasks here. And then, for example, if I want to configure that application plugin, I can do that by configuring that plugin convention, and then I can have that code completion here. I can configure, for example, the class name, the application default JVM marks, the typical things that the application plugin convention provides. Yeah, let's skip that. Another thing, I mentioned that earlier, for example, that self-referencing build scripts. I declare a repository here with that Maven stuff. I could use, like, I have support for Maven Central, that code completion. And now, maybe let's show you what I meant by that dependencies, or that Gradle API that does not suit very well yet a Kotlin build script. So if I say Maven, I have now, damn it. Like here you see that there are 3 different methods here to declare Maven repository. There's this Clojure block here, which comes from the Groovy world still. Then there comes this action block, which is the Java equivalent we offer. And then here's this idiomatic Kotlin solution you would like to use in your Kotlin script. So I would say that the first one can be, to make it more readable or more usable, it would be nice to hide them or to not make them available in a Kotlin build script. So that's something, for example, we haven't solved yet. So and then you do it like this, yeah, and set the URL. Unfortunately, Kotlin does only consider property syntax if you have a setter and a getter, and there's no URL getter, so you have to declare the getter here, like this. Yeah, that's one thing. Maybe another example, if we want to have, so if I want to create a task, I can have the task, give it the type of that task, and then give it a name. Typical thing, we create a source jar, and then you have the code completion, or with the API the jar task provides you can use. So I can say var to this source, and then I can do exclude whatever, and then you have that support. What you get in here is a file, and you can yeah, have the normal code completion. That's quite nice. And then, if I don't know if you're aware of copy specs. So copy specs are a way to share custom logic you use in different copy or jar tasks. So for example, I have now this one, which is a val, which is a non-changeable variable in Kotlin, and then you can say with and provide that one, and then it's pretty yeah, you see what I mean. I can rename that to some copy spec, and it should find all of them. Yeah, that's kind of what's currently there. If you want to try that out with IntelliJ, you need to actually you can use the latest IntelliJ release, and you need to update your Kotlin plugin to the latest milestone release, but then you have that functionality basically available. Maybe as another example, or one example left, is there's already, or the JetBrains guys, they offer a thin layer on top of the existing Kotlin build script. So maybe, what do I remove? Let's remove that. So here we have, damn it. Here we have a Kotlin build script that builds an Android app. And if you compare that Android block actually, which provides that custom logic on top, it looks quite similar to what you know already from the Groovy solution. So that's really nice, but you have way better code completion and stuff within, even with custom plugins, not just with Gradle built-in stuff. Yeah. So what's next? So at the moment, the Kotlin support in Gradle, we ship with Gradle 3.2. The next Gradle release will ship with Kotlin support 0.3.2, I think. We want to release or come to a version 1.0 by the end of the year, or really early next year, to be on par with the Groovy support. Till then, we need to catch up with some to stabilize the DSL and latest DSL features or functionality that are available in the Groovy DSL, like, for example, that custom plugins block. We currently, or I think, I'm not sure if that's already in Gradle 3.2 or shipped with Gradle 3.2. We worked on performance, like what we did for Groovy 2 is like, if you have a build with, I don't know, 4,000 build scripts or something, you can imagine if you compile all the build scripts every time from scratch, that's kind of slow. So I mentioned earlier that Kotlin is statically typed and should be performant, but actually what it has been in the past, at least in our build script, is that the builds have been slower in terms of processing because we haven't cached, or we haven't put that effort into the caching, and now we cache the results of that compilation, so we don't compile all those 4,000 build scripts again and again and again. One limitation we saw already in my example is that the settings.gradle file at the moment is only Groovy, so we're not sure yet if there will be a settings.gradle KTS file, probably, but it's not clear how we do that. At the moment, it's related to that. You have to declare that explicitly, that your build script is build.gradle KTS and not build.gradle. And last but not least, there's an update mechanism. We discuss internally a bit more about updating and how we want to ship features faster. Like, for example, Gradle releases every, let's say 6 weeks, something like this. But what happens if the Kotlin project offers something significant value? At the moment, you have to wait till the next Gradle release. But at the moment, we are discussing things like breaking that up and making that, having those things like the Kotlin support, but also like other features, their own release cycle, and make it easier for them to update. Or you can update as a user to newer versions of, for example, that Kotlin stuff. Are there any questions? So before I have my question slide. Again, I work for Graylink. The nice thing is you can work from home. Yeah.
Did I understand you work for Gradle?
Yeah.
And you can't push your plugin to the official repository, your Kotlin plugin?
No, the Kotlin plugin for writing Kotlin is provided by the JetBrains guys, and they did it on purpose that they haven't pushed that plugin into the Gradle plugin portal. There's I have the link to that tracker. I don't know what the reasoning behind that is. They are discussing it to push it there, but I would go with the Nebula plugin. It's way more convenient, to be honest. Any other questions? Perfect. I'm done. Thank you.